Welcome to the Mizzou Asphalt Pavement and Innovation Laboratory, or MAPLE. I'm Professor Bill Butler. Let's have a look around the lab. First of all, you're probably really annoyed when you hit potholes on the road and it jars your vehicle and your body, and we hate them too. And so that's one of the things we're trying to fix in this laboratory, and so much more. You can say hi to Punya, who's working on an asphalt binder specimen mold. And beyond the theoretical, we need to do physical experiments to really understand this material we're trying to fix and optimize and make more sustainable for the planet. And so this lab is all about innovation through integration of testing, modeling, and field work. So let's talk about the physical testing. One of the things we're trying to test is the liquid asphalt binder that holds the road together. So this is refined from crude petroleum, and it has to be tested in many different temperatures and different shapes. Low temperature is really important for wintertime cracking considerations. So we have a viscoelastic asphalt bending beam rheometer that does just the trick for that. Over here you'll see a dynamic shear rheometer that tests a smaller disc-shaped sample of asphalt, kind of in a twisting motion, and it can be done at high and intermediate temperatures. And we have another unit over here that allows us to extend to even higher temperatures or lower temperatures and do suspensions, things like, well, when we put ground tire rubber into asphalt, sure makes the asphalt more durable. It makes it more sustainable as well, a little trickier to test, and so we're set up to do just that in our laboratory. Other recycled materials we look at are reclaimed asphalt pavement, which is old pavement ground up and used into new pavement, roofing shingles, which are rich in asphalt that come off the roofs of old buildings. And the latest and greatest we've been working on is the use of waste plastic in asphalt. So we have a major waste plastic problem in the United States and really around the world. So we've teamed up with Dow Chemical to figure out how to grind this up, change it chemically so that it can be reincorporated. We call that a circular economy approach, where we can take materials and they won't be single use anymore. They'll be used over and over and over. One of the things that we're very famous for in our laboratory is testing the asphalt mixture, especially at low temperatures. This test over here is called the disc-shaped compact tension fracture test. It takes place in this cabinet here. This was an invention about 10 years ago, and we've been putting it into the mainstream ever since. It drives a crack across the asphalt, as you can see here, and the energy required to drive that crack is very much related to what happens in the field on a cold winter's night. We can translate the lab to the field through modeling, and so you can see on the screen here an example of our 3D finite element analysis that helps us link lab tests to the field. As we go through this part of the laboratory, you see a couple of our students, Hamid and Bainam, are preparing specimens for more mixture testing. Sometimes we'll have to invent a new mixture test in order to be able to characterize the thing that we need to address a new problem. And so as I make my way over here to this so-called universal test machine, or UTM, I can do things like test asphalt in indirect tension, where we put a compressive force on a circular specimen, and by doing that we can indirectly create a splitting tensile force in the specimen. It's another cracking test for low and intermediate temperatures. We can also, in the UTM machine, cycle cylinders of asphalt to get a fingerprint across time and temperature of low strain phenomenon, and that could link, let's say, as an aircraft moves across a pavement, we can predict how much it's going to bend under that loading. We can also cycle this and say, after 1 million load repetitions, is the asphalt still going to hold up, or is it going to have a fatigue type failure? The last thing I want to introduce is the concept of our other laboratories in Maple. So we have 3 other laboratories in addition to our showcase lab here. One of the laboratories allows us to do cyclic wheel testing underwater to test the asphalt mixture's resistance to permanent deformation and to moisture damage. And we have a host of other tests at our other laboratories. And one of our laboratories is just the field itself, so putting sensors in the field as part of smart cities, smart pavements, and partnering with agencies like MoDOT, Federal Aviation Administration, and administrations around the world. So with that, I'd like to wrap up our lab tour. Thanks for joining, and we welcome you to Maple anytime you can visit here in Columbia, Missouri. Thanks.